How's it going, everyone? Welcome, Euler Gonzalez. And today, let's continue to explore about this chapter of limiting scope exposure. So, because in the previous videos and chapters from this book of You Don't Know GS Yet, written by Kyle Simpson, a software engineer with over 20 years of experience, the idea here is to understand what is the things that are around JavaScript, not only technically, but also things that are non-technical. So, for example, is that who made the language, why the name of JavaScript, who owns the legal trademark, who oversees that JavaScript work as expected, or you can now, or the language can be enhanced, which is part of the TC39 group, and what this group does, and what is the goal of this group, and why, in order to guarantee the JavaScript is compatible, we have these things called polyfills that actually provides now fallback to all browsers, so JavaScript can be future proof, or aka backward compatible. In contrast with HTML and CSS, that those language are not that. JavaScript, because it wants to guarantee the compatibility and the interactivity of the applications, well, they define, the TC39 group define is a set of polyfills or code that you can add to your library or any piece of code in order to guarantee that that particular feature, so for example, promise dot finally, right, prior to EX 2019, you can actually use that. All right, and now we have this new particular features that bring us is the reactivity in our frameworks like signals. Just to mention that the language is constantly evolving, and because of JavaScript, because of this language is in this state, we need to understand how these things work. And it works as a compiler language rather than an interpreter, or aka a scripting language. So this compiling kind of language, okay, it is based not on how the code is processed, and it is based on how the code is analyzed. And the observable behavior is that how it processes now syntax errors, early error, and hoisting, right? So in order to understand now what this language is doing behind the scenes, one must understand that when your code is evaluated, like in a compiler language, your code is something that is going to pass through a analysis, through an scope analysis, and because JavaScript has particular syntax with specific definitions, that anytime that it detect that, is going to create now a scope as well as an environment record that has the association between the variables, the identifier, and the variables and functions. But again, this particular nature of how this JavaScript works is that when you code leave the GS editor in or any text editor, usually that is bundled up, that is transpiled into a more evergreen JavaScript that can be understood by any browser, and then look at the bundle up and ship to the JavaScript engines. So when that engine receives that code, it's going to now is pass through the engine, and it's going to parse it, to convert that into an abstract syntax tree, and then pass through a compiler for further optimizations, and finally execute the code. So because the JavaScript engines is something that is based on the spec, on the implementations, but all of them must stick to the law. You can also find some nuance or deviations of the behavior of JavaScript in the Appendix B. So engines can implement these new features made by the TC39 at their own pace. This is why we have websites like Can I Use It to describe is, hey, at this moment, can I use these particular features? Is this features widely supported? Do I need to some sort of transpilation or polyfill to make that available to all the browsers? And also, once you understand now how JavaScript works, it is important to look at what are the different approach that we can have when we write our code. So functional programming, object-oriented programming, and as well as the procedural, all right? And understand also that JavaScript, because it's now an ever-evolving language, we have now this thing called strict mode that give developers this guidelines of have a good chance, or to write JavaScript code that have a good chance for further optimizations and running your code, right? So all of this is just to briefly mention what are the things around JavaScript, and then when you dive deep into the technical aspect, so for example, the variables and values, what is a value, what is the purpose of a value in the language that helps now as a that describes a particular state of your programs, and how those programs are now analyzed by JavaScript, right, and how they can cooperate as or act as a one at runtime via the ES6 models, or by sharing now the global state, right? And understand what type of values we can have in our programs, so numbers and string, and they actually have is a particular spec that also follow. For example, in the case of numbers, is the IEEE 754 that describe now how these numbers will go into the representation of these numbers, all right? As well as the string that describe now the representation of all of this symbol and how they map to a table, all right? Previously we have things as ASCII that only represent is the English alphabet, but right now we have is Unicode that actually is an effort, a huge effort for a lot of developers and engineers that works in IBM or with any of this backbone language, so C++, C, that they features or their products are shipped to different cultures. So now we have the benefit of using is that particular format, universal transform format, the Unicode, right? That represent is a vast collections of symbols, right? So from 0, and it is using is 16 bits to represent that. So from 0 to 65, 3535 number, all of them represent is what is known as the basic multiplane, all right? So anything that go beyond that is known as the astral plane, and this is when you find things like emojis and composition of emojis, right? That's quite interesting in order to understand what are the type of values that we can represent here. And also we have is the Boolean as well as a type of emptiness, null and undefined, symbol, big int, and also objects, collections of values as well as arrays or even array of objects, as well as functions and the collections of functions. And this is important because functions now help us here is to understand that you can now not only define functions here, a set of instructions, but also you can held those instructions inside of a variable or a container that you can use that in any place of your code when you see fit, right? So because we have now these definitions or this special type of functions of how you can define your functions as functions declarations and functions expressions, all right? This is just to describe the basic of the functions and how these functions declaration and variable will behave as well. So for example, with hosting. So another broadly speaking feature is the is how you can now compare values and how you can coerce values, transform one value to another via the triple equal or the double equal, and what this algorithm is doing behind the scenes, known as the abstract operations, and why it is important for us to understand what it's doing, not to memorize, but to truly understand that anytime that you use now a triple equal, what's going on, what's happening behind the scenes, right? Because it's comparing it with the same type. And is not coercing those values. And also how you can now transform or how you can now coerce, transform one value to another. Another important high-level feature of JavaScript is how you now organize is your code, whether it's a function, as a model, or as a class. And each one of them has not only its trade-off, but a particular behavior that we would like to know, and we want to do, and I'm going to explain that later on, right? So this is just the high-level features that we can have in JavaScript, and then going into low-level feature, at least based on this particular book, such as how do we now do things that are common. So for example, iterate through collections. What is the iterator? What is the iterator protocol? What is an iterator? What is an iterable? As well as what is the properties of a function has. So for example, closure, which is now how a variable resolve identifiers in the value of this, or what is this, which is now exposed like an object by to the function by JavaScript, that you can have access to the execution execution context, aka anytime that this function is called, you have access to this particular object, right? So, and another is how do you work now with objects, especially the prototype object, a particular feature of objects in JavaScript. Especially is how do you now answer questions when you have now objects, different objects, and you somehow, instead of actually rewriting all of your code, right, or start from the scratch or reinventing the wheel, as people like to call it, wouldn't be nice to have now an object that contains now is the properties or the data as well as the functionality or the that we can have access to. So instead of writing that, we can reuse that. For example, right? This is known as how you can access to the properties that is not in your object, but is now in another object that are linked. known as the prototype change. And this is just to solve this question, is that, hey, how this prototype change actually works. And it turns out that all of this is by delegate the property access to another object. So you are telling JavaScript, hey, do we have this property on this object? And it say, if it's not, so let me take a look now at this particular reference known as the prototype. In the old school is under the dunder proto dunder to indicate that this is a private private property. Don't mess with this to developers, and then you link that to other developer as well, right? Or you link to other objects as well. So now you are delegating to JavaScript, hey, this resolutions. So, and also is that how you combine now this object property link with the context or with this context. So in other words, at runtime you want to pass now is some values, but you want is to guarantee that if that value doesn't exist at runtime, you want to figuring out if that exists along the prototype chain. This is actually some advanced topic. We're going to cover that in later videos, but this is just to describe briefly is now the nature of JavaScript, all right? Not only for the technical aspect, for low-level features, but also is things that are around JavaScript, that non-technical stuff. So because here, this leads us to now understand what scope and closure is. And here in the JavaScript, as I mentioned before, the observable behavior is that JavaScript behaves like a compiler language when analyze the code rather than an interpreter. And this is when it comes to analyze syntax errors or early errors or hosting. Okay, so in order to now understand what hosting is, by exploring that certain features like functions, declarations, block, and the catch in the try and catch actually create now an environment record, which is the place where JavaScript used to put now is variables or functions and link with a particular identifier, right? Or associate with a particular identifier or a name to that. So this process, okay, this scope that happened is in this particular declarations is something that when you have now variables here in your scope, starting some questions starting to arise. Okay, and this question is like, hey, how do we know? For example, is when we have now variables in the same scope, what happened to those variables that have the same name? All right. So in the case of var or functions, well, it's going to now it's gonna prioritize is the definition, and then it's going to hoist that, aka it's going to put now those identifier at the top and initialize that. So another question is that what happens if we have now is identifiers with this we have the same identifier at different nested scope. So it turns out that this is known as shadowing, and anytime you create now a scope, whether it's a function or a block inside of another nested scope, right? Internally, JavaScript now holds a reference to the outer environment record, right? Via the outer env. So this is the way of how you can now, for example, is at the deepest level have access to variables that are outer the enclosing scope. But if you have now the same name, what happened is that it's going to be shadowing, so you can't have access to the previous declarations. You can create a copy from that, but you can't have access lexically in there. So we look at what the function scopes is, what the block is, how you can define now scope. We'll also look at some metaphors here. And with the functions, anytime that you now use is, for example, is var and let, and you define now is a scope inside of that, because when you now define the functions and variables, the variables are hosted at the function levels, and let are hosted at block level. All right. We also look at another scope like parameter scope. The TLDR is that don't fuss with this. Don't shadow parameter don't shadow parameters names. You can take a look at that if you want to, but the other scope is the arrow functions, and how now the arrow functions are being used, but as a way to now is quickly create now and maintain the lexical environments. So in other words, if you do want to have access to a particular variable, right? With the arrow functions, one of the problem is that if you don't have any name, you can reference that arrow function. You can, of course, attach that to a function expressions, which is great, but if that doesn't have any of the you can attach that to or you can assign that function, arrow function, to a variables, and then it's going to now hold that name or hold that identifier as it is. The other is that the function name description, or the function name declarations, and why this is useful, especially not only to allow you to have access to that identifier, but also is to describe what this function is doing, which is part of the functional programming. So with this understanding of the functions and the scope with block, we also look at another place of where we can now share different functionality, because at the end of the day, that's the main goal of scope. This is why this is a question that a lot of people might ask. So it turns out that this scope here, the main scope or the global scope, is a place where we can now put all of these different variables and now cooperate amongst them. So the way of how the browser does this is whether it is by using the ES6 models, ES6 import, or by now using is the so enclosing now that particular functionalities as models into its enclosing scope. So for example, is a function, all right? And the other is now attaching properties to the global objects. So this is one of the, there are several environments, or there are several global scope based on the environment that we can run JavaScript. So for example, the browser, as I mentioned before, the global scope, and how the global scope also now when you define variables and functions, you're going to attach those variables to the window object. Unlike let and scope and cons, they don't do that. And then you can access to the window ID based on the you can access to the ID of an element in the DOM. So another place we can find is a global scope is on the web workers. So unlike the browsers, this doesn't have access to the DOM, so we can access to certain particular features, all right, such as the navigator. But when you define var or function, they're going to be attached to this name or global scope known as self, right? So far, so good. The other is the RELP, or the developer environments, developer tools. And see, we're gonna see that how specific stuff doesn't behave as the other environments or a true environment. And also is the ES6 models, which this doesn't behave. This, despite that, this doesn't have any top global model. All right, you define your variables and functions, and you can have access to the or export that via the export keyword. And another place is the node environment. So this, anytime that you load a file here, it means that by the time that you do that, each one of those files are loaded as a single model. Right, previously CommonJS and now ES6. So they don't have a way to have access to the global variables until 2020, where now it exposed is the global this, right? Where you can now attach is some variables to that. But anytime that JavaScript loads this or Node loads this GS file or modules, it's like you have access to the specific functionality that is exposed by Node. All right. So I mention all of this, all right, because when it comes to understanding now the scope, it's also important to understand now variables and how variables declarations works and behaves. So for example, is functions and var. So what is the behavior of this, which is, hey, how can I look now at the or what is the observable behavior of var and functions? So anytime that you define that inside of a global scope, it's going to be attached that to the window object, as I mentioned before. But if you define that inside of a function, right, it turns out that it's going to be hosted, is even though in the global scope, it's going to be hosted and initialized as undefined in the case of var, or as the value in the case of a function, right? And if you have now identified with the same name, the priority here is if you have the same identified with, if you have name identified with the same name, but with different declaration var and functions, functions have more priority than that. Okay, so because of this behavior of hosting, that hosting only happens is with var and functions declaration. You can take a look also at the ECMA script that is describing is that, hey, this is now hostable declarations, whether it's functions, async functions, generator, async generators, classes, as well as let and cons and variable statement. So this definition or this point that I'm describing here of the hosting, when you assign now data, when you assign a function as a value, or when you assign a function as a value known as function expression, they don't host. All right. Also, we look at what happened now with the or how it behave let and cons. So because let and cons now are specifically to block, and block are now a scope in itself. So anytime that you, for example, describe is or you define a let and cons pass appear anytime that you define a let and cons declaration, pass appear the statement, all right? Well, it turns out that there's a question here. So what happens? So what happens in that moment when you define when you declare the let and cons definition, and then you somehow wants to have access to the identifier. So it turns out that it throws you now a reference error, and this is known as the temporal dead zone. So this is just not only happens for let and cons, but also for var and function. But the thing here is that let and cons, we have an observable behavior of that. So in order to avoid this kind of behaviors, always put your let and cons at the top of your block. And you might wonder, why do we even need about let and cons? And that's a good question. So because this particular identifier, for example in the cons, help you now to say, hey, if you define this identifier, that won't be is redeclare or reassign. You can only do that once. So it makes sense. For defining, for the readability of the code, you say, hey, well, this is now a constant. But it turns out that if you, for example, wants to implement hosting features, so for example, if you say now cons, you define your block, and then not immediately after, but sometimes later on in that block, you define your cons. So if you try to host that with an undefined value, and then at the time of that statement you assign the value, that doesn't how constant work. This is not the intuition. But if you now define cons with the identifier and it needs to be initialized, and that'll be done for the rest of that block, so it makes a lot of sense for that case, but doesn't make a lot of sense with the let case, right? When you can only is, you cannot redeclare here. So the thing with the let is that the community of the TC39 say, hey, it is very problematic that anytime that you define is a the same identifiers or the same name identifiers in a particular scope, that's a thing that cause a lot of bugs, right? So, and if you find yourself in the need to do that, so please wrap this into an scope, perform the operation that you need to that in that scope, and then now that'll be done, right? So the idea here is to prevent this particularly not only name collisions, but also this kind of bugs that can happen in your code. So I do think that this is very, very revealing, but it turns out that why doesn't follow the behavior, especially with the let, with var, that's to me something that is puzzling, right? But again, I do think that if you're going to implement now this feature let and cons, because they are now in the same scope, so AKA you are going to find that in the temporal dead zone. So in any case, this is my justification or about the things of how this supposed to be. So in any case, so with that, all right, knowing that is also that when you, for example, want to know or once we explore about this let and cons behavior, as well as how it behaves inside of a looping, all right, so it behaves as expected, for in, for of, while, except for with cons, which makes a lot of sense. we are now here looking at the limiting scope exposure, all right? Because there is a concept in software programming that, hey, if you want to make your applications robust and secure, there's several particular approach. One of them is to prevent access, right? And the other is encryption. Here they're looking is at the preventing access, right? And preventing access has shown that it's not a good strategy. This is not my own experience, but also is based on the you can look at the Marlin Charles Marlin Moxie Pike. No, Moxie exactly is Moxie Marlin Spike. Okay. And in that particular podcast, all right. So Moxie Marlin Spike, which is of course is a pseudonym of a cryptographer, which is quite interesting. That he used that and not his real name. And that is mind bending. Not even here. They put their name here. That's interesting. That's interesting. So in any case, there's actually a very interesting podcast from here. You can take a look at that. But here is exploring this two strategy about security, and this is in this particular chapter we are exploring about that, right? So the principles of least privilege is that you are going to provide that user with the minimal amount of rights to have access in their credentials, right? This is a defensive posture, and anytime that you are in defense, you are like in a losing strategy. That's interesting. That's quite interesting. In any case, but it turns out that this particular principle of security from an architectural high level component design, which, hey, if one misbehaved component or if each component is connected with the bare minimum capabilities, okay, so if each piece is connected with minimum necessary capabilities, the overall system is stronger from a security standpoint, because if a component is misbehaving or failure, it won't compromise the overall system, right? This is, if you can think, for example, like submarines or ships or starships, right? You do want to actually guarantee that each individual departments somehow they can now is something when run, they can be now detached from that or won't compromise the overall system, which is the submarines or the starships. And this is from high level designs. And when it comes to low level design from variables and components or variables and the scope, here Kyle Simpson mentioned is this concept of the least exposure. So why we're looking at the least exposure? Because it has several advantages. And the thing here is that why exactly is that why do we're looking at for the principle of least exposure? Is because we want to minimize is a scope variable exposures, right? In each scope. Why do we want to minimize the variable exposure to that? First thing first is because you are avoiding is naming collisions. This is pretty straightforward to understand that, right? So for example, if you have a for loops and if you're using now a single global index for all of your for loops, and if one piece of your code actually is using that for index, and then some other piece of your code now uses index, well, the second time that you cast the for, of course, you're going to be in a wonky state. That French does that. And the other is the unexpected behaviors. So if you expose, for some reason, some private behaviors, some private methods, and if somehow a good or ill-intent actor access to that, then it's gonna run into some unexpected behaviors. And this is also because how Opurity works as well. And the other yeah, exactly. If you have a program that assumes that an array contains all numbers, but someone else code access and modifies the array to include booleans or string, the code may be misbehaving in an unexpected way. Okay, if you assume that an array contains all numbers, exactly. So hey, you are assuming that I'm just going to receive is now an array of numbers, and then if you somehow now receive is a boolean or a string number, so it's going to behave now in a very wonky state. And the other is the unintended dependency. If you expose now several of these variables unnecessary, all right, to private, it will be very hard to refactor in that in the future, because now you cannot easily refactor that variables or function without potentially breaking other part of your software. And this is causing the unintended dependencies. Exactly. I do think that this unintended dependency exposure is that if you for somehow expose now or overexpose variables and other functions, that makes a lot of sense. If you overexpose those variables and functions, those who consume that, if you somehow needs to refactor that, it'll be very hard for the owner of that code, or the responsible of that code, to refactor that without breaking the code of all of those consumers. So what you can do is now a versioning of this. Hey, this is now the version 1, and then now the version 2. So you can now redirect all of the traffic of all of the features, so you can tell to all of those consumers to redirect now to this particular version. This is how you can solve these unintended dependencies. So here we look, right, on hiding in plain function scope. You should now be clear why it is important to hide our variables and functions declaration in the lower, most deeply nested scope as a way to prevent this overexposure and to now avoid is name collisions, unexpected behaviors, and unintended dependency exposure. All right, that'll be very hard to refactor and then you eventually have to create now a version of that. Yeah. Absolutely, absolutely. um, we are already seen the let and const keyword, which are block scope declarator, and we'll come back to them in a more detail shortly. But first, what about hiding var or function declaration in a scope? That can easily be done by wrapping a function around a declaration. And let's consider an example where function scoping can be useful. So okay, so here we're looking is now the reason why we are now uh, well using a scope to scope variables, var and functions, and why in the utility of the functions. I don't mention why hosting, especially with all of the things, but the reason of hosting, or at least I present in the case of hosting, is to describe is the executable code first, executable function codes first, and then function declaration, and with variables is to use as conveniently semantically in your programs. So for example, in a catch, all right? So when we are looking now at the scope, all right, as a way to understand that this particular problem that we have in our programs of naming collisions, of unexpected behaviors, and unintended dependencies, all right? So with var and less, block is very straightforward. With let and const, enclosing that scope is very straightforward, okay? But when we use at var and functions, especially with function scoping, all right, we can use now this function scoping to wrap them here into its own module here, right? And because we can wrap this into its own enclosing models, right? We can now is not only is define this function enclosing here, all right, and then attach that to the global scope, but also use that scope or that function enclosing scope as part of a variables, as a function expression, or as immediately invoke function expression. So now if you do want to now access to factorial, you can now get the benefit of this. And then we're looking at invoking function expressions immediately here. And immediately invoke function expression is useful when we want to create a scope to hide variables and functions, since it is expressions. And this is the reason why we're looking at this immediately invoke function expression. So anytime that you want to now hide hide the variables and functions definitions, all right, to creating an own scope, immediately invoke function expressions are useful to that, and it can be used in any place in JavaScript programs where an expression is allowed. An immediately invoke function expression can be named as with hide the catch, or much more commonly unnamed anonymous, and it can be standalone or before or as before part of another statement, hatch the catch, that return the factorial for this function reference, which is then assigned to the variable factorials. For comparison, here's an example of a standalone immediately invoke function expression. And we can also have another type of operator that indicate that this is an immediately invoked function expression. Okay, unlike early with hide catch, whether the outer surroundings were noted as being as the optional stylistic choice for the standalone immediately functioning expression. They are required. They distinguish the function as an expression, not an statement. Immediately functioning expression, they are required. They distinguish the function as an expression, not as a statement. AKA, and for consistency, we use this. And AKA, technically the surrounding here's aren't as the only syntax to ensure the function is an immediately invoked function expression is treated by the JavaScript parser as the function expression. And we'll look at some other options in Appendix A. So functions boundaries. Beware that using an immediately invoked function expression to define scope and can have some unintended consequence. Depending of the code around, because an immediately invoked function expression is a full function, the function boundaries alter the behavior and certain statement of construct. Okay, so for example, if the code you need to wrap a scope around has return this, break, or continue, immediately IIFE probably is not the best approach in that case. You might look to create a scope with a block instead of a function. Scoping with blocks. You should by this point feel fairly comfortable with the merits of creating a scope to limiting identifier exposure. So far we have looked at doing this via the function IIFE. Okay, scope. But let's now consider using let declaration with nest block. In general, any curly braces, curly brace pair, which is statement, will act as a block, but not necessary as a scope. A block only becomes a scope if necessary to contain its block scope declaration. It has let or cons. So consider this. Okay, this is now a scope. All right. Now we know that the block needs to be a scope. Okay, and here this is also a scope. It's activating on each iteration, so we check that, right? But it's the let and the let, and here I is just a block, not a scope here. But it's because the way of it's because a block only becomes a scope if necessary to contain its block scope declaration. Let and cons. Interesting. Okay. So that particular block becomes now a scope if that contains the let and cons declarations. Scoping with blocks. So not all curly braces pair creates block and thus are eligible to become scope. Object literal use the curly braces pairs to delimit their key value list, but such object values are not scope. Class use this and curly braces around its body definition, but this is not a block or a scope. A function uses this around its body, but this is not technically a block. It is a single statement for the function body. It is, however, a function scope. And the curly braces paired with a which statements around a set case clause does not define a block scope. Again, only when we use it let and cons, it becomes a block scope. Other such non-blocking examples. So for example here, is not a block or scope. Or it's not a block or scope. It's now a function scope. It is not a block scope, it is a function scope. Other than such non-block examples, like this, can define a block attachment to a statement like if or for, or stand alone by itself, and see the outermost here. Curly brace pair in the previous snippets and an explicit block of this sort. It has no declarations. It is not actually a scope, serve no operational purpose, though it can still be useful as a semantic signal. Explicit standalone blocks have always been valid JavaScript, but since EX6 let encons they are quite rare. However, post EX6 they are standing to catch a little bit. In most language, to support block scoping, an explicit block scope is an extremely common pattern for creating a narrow slide of scope for one of the few variables. So following the poll principle, we should embrace this pattern more widespread in JavaScript as well. Use explicit block scoping to narrow the exposure of identifier to minimum practical. So in an explicit block scope can be useful even inside of another block, whether the outer block is a scope or not. For example, here, if something happened here, this is a block but not in a scope, only becomes a scope is when you define is a let or cons here. Notify others, all right, or recovery from something. So if something happens and this is a block but not a scope, you can define something here to notify others, right? Or return this, for example. Exactly, to return this for examples. Or you can do this, recovery from something. Here's a curly brace pair inside of the if statement is an even smaller inner explicit block scope for message. Since that variable is not needed for the entire if block, most developer will just block scope message exactly to the if block and move on. And to be fair, when there is only a few lines to consider, it is a toss-up judgment call. But as code grows, those overexposure issues become more pronounced. Exactly. As the code grows, those overexposure issue becomes more pronounced. So it doesn't matter enough to add the extra pair and indentation level. I think you should follow is the principle of least exposure and always within reason define the smallest block for each variable. So I recommend using the extra explicit block scope as shown. Exactly. This is if you want to now say, hey, I want to diverge this code to do something else or to recover from something. So I recommend using the extra explicit block scope as shown. Recall the discussion of TDC errors from uninitialized variables. My suggestion there was to minimize the risk of TDC by putting it at the top of the block scope, all right, to prevent any of this TDC error. If you find yourself placing a let declaration in the middle of a scope, first things, oh no, TDC alert. If this let declaration isn't needed in the first half of that block, you should use an explicit inner block scope to further narrow its exposure. Another example with an explicit block scope is this. Var next month year. With an explicit block scope is this. Alright. So get next month star, next month and year. So you have now is functions scope or variables function scope, they string next month and year. So here you are doing is, hey, I'm gonna create now a new one where I can get that, associate those identifiers to whatever is needed, right? And then the next month update its value here. Holy hell. So in this particular block, what you're doing is to update those identifiers when you see fit. And then now ask the question, hey, is the next month is equal to 1 based on this current month? You want to coerce that into a number and get the model of that. All right, so if you somehow get is now 2 or 4, so on and so forth, and once you get that, you're gonna add 2 plus 1. All right, date 4 years, the month and the month. All right, and if you for some reason actually you get that, and if you get this to 2 or 4 and 5, so you're gonna get is a number, so you're going to get is a model of this, which is gonna give you is a number from 0 to 12, no, 0 to 11, exactly. That's what it's gonna do this. 0 to 11, if you do the mod here, exactly, from 0 to 11, okay, from 0 to n minus 1, okay, that's what you're gonna get here. From 0 to minus 1, all right. So yeah, that you got it. And also you get is the next month. So once you get is this. So for example, if you do get the okay, if you for some reason get 12, which is gonna give you 0, all right. Because if you get 1, it's gonna give you 1, but any in this sequence of numbers from 0 to 1, 0 is gonna represent now the last number, and 1 we're gonna represent is the lowest number until it reaches to that, right? So the only possible values that you can have here is from 0 to 11, right? So if for some reason you have now is 12 as a number and get the model of 12, it means that you reach to that, you have the 0, and once you add plus 1, and if you check that with 1, you say, hey, now year is so the year is 1. Because you're playing here with the model here. You're playing here with the model and how the models work. So the model will give you now is the reminder, right? All of this sequence until n minus 1. Okay. Until n minus 1. And then you're gonna get is this, right? The year, the string, and you're going to construct is now that. And so based on the declaration here, next month and year, and the current, it is. So current month is now inside of this scope, all right? And this is interesting because we are now playing is with the identifier here. Exactly. We are now developing intuition to develop is this identifier stuff here. And when we are going to be, and when do we need to use this? So why put current month in an explicit block scope instead of just allowing next month and year in the top level function scope? Because current month is only needed for those first 2 statements. It's because based on it is utility here. And the function scope level is overexposure. This example is small, so the hazard of overexposing occurring are pretty limited. But the benefit of the Paul principles are the best achieved when you adopt this mindset of minimizing scope exposure by default as a habit. If you follow the principle consistently, even if the small cases, it will serve you more as your programs grows. So here you define is this of the bucket, sort name by length. So what you're doing is just to get these collections, right? You check the length of that, and based on that particular length in this bucket, you're going to now is mm-hmm. So you have all of these buckets here, right, with numbers. And this bucket with numbers, if you, for example, wants to figure it out, if you have something there, if you don't have that, you're gonna create now is, well, a collection here, right? So you can think of this like in this bucket you're gonna create now is a series of you're going to organize here this bucket as a collection here now. And then once you have this, I would like to now is push that element or push the name into that index, right? And I want to do that over and over and over for all of this length that I find that out, right? So once I have my list of buckets fully formed, which each one of them contains now is all of this list of which contains now all of this list. So what I can do is, now that this bucket is already sorted, so I do not need to sort it, but what I do need to sort is what is inside of this bucket. Okay, sorted then alphabetically. Okay, and once you sort it alphabetically, I want to now is attach whatever sorted name has at that moment, and then put that the bucket, and do that the same. Sorted all of these elements, right? Sorted all of these elements in this bucket, and then sorted all of these elements in this bucket, and then append that list to the previous list that you already have, and so on and so forth, and you get it, right? Which is why this actually, what you're gonna return is a sorted names. Sort name by length. There are 6 identifiers declared across 5 different scope here. Interesting. First, you define the top level of buckets that you want to have access to. All right. This is mind-bending, because this sort of stuff is something that it requires you to understand what are you doing here. It requires deep understanding of what you're doing here. Absolutely. It requires a deep systematic way of what you are doing here. Exactly. To have a clear this is why you need to clarify your ideas, man. Oh, okay, absolutely. This is why it's so this is why it's so important to clarify your ideas, bro. Holy moly. And the only way to clarify is if you have the desire to understand that. These are 6 identifiers declared across 5 different scopes. And could all of these variables have exist in a single outer global scope? Technically, yes, since they are all unique names and thus not have no name collisions. But this will be really poor co-organization and will likely to lead to both confusion and future bugs. A block to narrow the scope. We split then out in each inner net scope as appropriate. Each variable is defined at the innermost scope possible for the program to operate as desired. Sort names could have been defined in the top level function, but is only needed for the second half of this function. To avoid overexposing that variable in a high level scope, we again follow the principle of least exposure, and block scope is an inner explicit block scope. And then we're exploring here at this where to let. That'll be all for this video. Take care. Bye bye.